Hi guys, so when teaching this to my students, of course we'd always start with our prior knowledge. I would review with the students our identity properties and also our inverse properties. We would remind the students that identity is the do nothing, it does nothing. So for addition, our identity is 0, so when we add 0 to a number it does nothing. So 7 plus 0 is still 7. For multiplication, our identity is 1. Anything times 1 will be itself, so 7 times 1 is just 7. So adding or multiplying by the identity does nothing. Also with the students, I would review the inverse property. When we do the inverse, we always equal the identity. So for addition, we're trying to make 0, and in order to do that, we have to add the opposite. So for 7, the inverse would be negative 7. So adding the opposite, 7 plus negative 7 would make 0, which is our identity. For multiplication, we're multiplying to get 1, as that's our identity. So when we multiply, we take a number like 2/3, and its inverse is actually the reciprocal. So for 2/3, it's 3/2. So multiplying 2/3 and 3/2, we get 1, which is the identity. Also with the students, and I didn't have this, but I'm going to make another one here. We would review the associative property, and I would review with my students that the associative property means that if I have 2 plus 3 plus 1, this is the same as saying 2 plus 3 plus 1. And we could also do this with multiplication, so if we have 2 times 3 times 1, this is the same as 2 times 3 times 1. And so I'd remove this with the students that even though we move the parentheses in the order of the operations, we're still going to have the same answer. Once I have this, I would walk over and start with the different functions. So when we have functions here, we have h of x and we have j of x, and our students would then be learning that composite functions are when we take one function and we're kind of putting it into the other and replacing our term x now with j of x. So instead of x being in the input, now we're going to have j of x as the input. So to look at this, we'll get this out of the way. So here our function h of x is 2x minus 6, where our input is x. But now we're going to take that input and we're actually going to make it x plus 6 over 2. So here we have h of j of x. And so we need to simplify this, so we have to start by taking our order of operations. So to start with this, we're going to move this down a little bit. So to start, we rewrote, instead of saying we're dividing by 2, we're multiplying by 1/2, as they are equivalent. So now I have 2 times 1/2 times x plus 6, and then after we're finished that, we're going to subtract 6. So next what we're going to do here is rewrite this. And so we know by the associative property that we could rewrite this a little bit, and here we have 2 times 1/2. Then we have our rest, x plus 6, and then we're going to subtract 6. So now we know 2 is the same as 2 over 1. 2 over 1 times 1 over 2 will actually make our identity, or 1. Scroll up a little here. So I'm making 1, so I can replace 2 times 1/2 with 1. So I have 1 times x plus 6, all minus 6. Well, 1 times all of this is just the same thing, so we'll keep this here. And we have h of j of x is now x plus 6 minus 6. Or we also know instead of x plus 6 minus 6, we could say x plus 6 plus negative 6. Well, positive 6 and negative 6 are inverses, and so we know that they actually make 0. Well, making 0, we know by x plus 0, that's our identity. It does nothing, and so it's just x. So we could simplify this down instead of having all of this here to just give us x. But we also want to check and do it the other way and take our j of x function, and instead of having x for the input, we're actually going to input all of h of x. And so I'll have this here where I have 2x minus 6 plus 6 all divided by 2. So we start here, and as we did before, we take our divided by 2 and we rewrite it as 1/2. So we have 1/2 times 2x minus 6 plus 6. Well, with our associative property, we're going to start with inside the parentheses. So if we look inside, we have minus 6 and a positive 6. Well, those make 0 as they are inverses. And so we can simplify this and we'd have 2x plus 0. Well, since 0 is the identity and 2x plus the identity does nothing, so 2x plus 0 is actually just 2x. So then here we have 1/2 times 2x. Well, 1/2 times 2x, we're going to rewrite this because of our associative property. And we know we can have 1/2 times 2. Well, 1/2 times 2 is the same as 1/2 times 2 over 1, which makes 1. And we could rewrite this here like this. So we have 1 times x. Well, as 1 is the identity property of multiplication, anything times the identity does nothing, and we know it's just x. So here we have j of h of x is x. Nicely here we realize that h of j of x is x, j of h of x is x, which means that these are actually inverses of each other. And the identity of a function is x. So here that's how we end up with that. So now let's try another problem. So we have this function here, v of x is equal to 2x to the third minus 7. And so we need to find the inverse of v of x. So to do this, we're going to sit and talk about our operations being done to x in this function. So here we have our x here, and once we take our x and put it into the input, we're going to have to cube that number. After we cube that number, we're going to multiply by 2. And after we multiply by 2, we're going to subtract 7. Oops, 1. Move this down here. So here we said the operations of v of x, I have to cube, then multiply by 2, then add negative 7. Well, we know that we're inverse, we're going to do the opposite. So we're going to work backwards doing the opposite. Instead of adding negative 7, get this out of the way. Instead of adding by negative 7, we're going to add positive 7. Instead of multiplying by 2, we're going to multiply by 1/2. Instead of cubing a number, we're going to take the cube root. So by doing everything backwards and doing the opposite, we create our inverse, which then makes z of x. So here I have a number x, I add 7, I multiply by 1/2, and then I take the cubed root. And so here we have the inverse of v of x. But once we have our inverse, we now need to try our composite functions. And so we're going to take v of x here and we're going to take z of x and put it in for the input and then do vice versa. So to start, I took our z of x here, all of this, x plus 7 divided by 2, or x plus 7 times 1/2 to the third root, and took it and input into the equation 2 times the number cubed minus 7. So now we're going to have to work through this and see how we can change different things. So we're going to want to simplify. Here I have a to the 1/3 power and to the third power. And so what we can do with this is they're actually going to cancel out as their inverses, and they do nothing. And so we're left here with 2 times a number plus 7 times 1/2 minus 7. Well, we know that we could rewrite this a little bit. And so I have 2 times 1/2 times x plus 7 minus 7. Well, 2 times 1/2, as we saw in the previous problem, we know where these are reciprocals, and so they equal 1. But by the identity property, we also know 1 times anything is itself. So we're actually left with this here, x plus 7. But I'm subtracting 7. We could also look at subtracting 7 as adding negative 7. And we know a number plus its opposite is actually 0. And so here I have x plus 0. Well, this is the identity property, and x plus itself, x plus 0 will just be itself, and so we have x. This is a good sign since we think that z of x is the inverse for v of x, and we're checking to see. So now we're going to need to do the opposite. And here, take z of x, and now remove the x and replace it with the function v of x. And now we get all of this where I have 2 times the number x to the third root minus 7 plus 7, all times 1/2, and take the cubed root. We're hoping to get the same answer here as x. So the first thing here, what we're going to do is we have a minus 7 and a plus 7, or a negative 7 and a positive 7. And these are inverses, and they make 0. So here we made 0. Now I have 2x to the third plus 0. Well, this is the identity. Anything plus 0 is itself because it does nothing. And so now we have here 2x to the third times 1/2, all to the third power. So we're going to take this and rewrite this. I have my 1/2 times 2x to the third, all to the 1/3 power. And so we know 1/2 and 2 are reciprocals. Well, 1/2 is the reciprocal of 2. They are inverses, and they're going to make 1. And so here we have 1 times x to the third. Well, 1 is the identity of multiplication, and so we know that anything times 1 is actually itself, and so we can simplify to x to the third, all to the 1/3. But we know that this is a cubing a number, and this is a cube root. They are inverses. They do nothing. They cancel each other out, and I have x, which means that we were right when we did our inverses here, and that v of x and z of x are actually inverses.